Let's look at section 2.3, linear functions and slope. And our objectives here are to calculate a line slope, write the point slope form of an equation of a line, write and graph the slope intercept form of an equation of a line, graphing horizontal and vertical lines, and then those others. You can obviously read those. But we have some things that you need to review before we can get started in this, and it's some basic formulas or information needed when we're working with these equations of lines. First one is the slope formula, y2 minus y1 over x2 minus x1. That's when you're given 2 points. I don't have it written on here, but the slope can also be called the rise over the run, which is just the change in y values over the change in x values. Slope intercept form is y equal mx plus b, where m is the slope, b is the y-intercept. Point slope form, on my sheet it's a little messed up, but it's y minus y1 equal to m times x minus x1, where y1, x1 is a point and m is your slope. The general form for the equation of a line, ax plus by plus c equals 0. Little information about vertical lines. They have an equation of x equal to a constant, and vertical lines have no slope. And horizontal lines, their equation is y equal to a constant, and they have a slope of 0. Most of that should just be a review from some previous class you've had. So let's get started with the slope formula, where we want to find the slope of the line that passes through those 2 points. Well, we can label our points as x1 comma y1 and x2 comma y2. All that means is we have a first point and a second point, and we'll use the formula y2 minus y1 over x2 minus x1 and make that calculation. So y2, that doesn't look very good. y2 minus y1 is going to look like negative 2 minus a negative 4. x2 minus x1 will be 4 minus 6. So setting up those values, y2, which is negative 2, minus y1, which is negative 4, just subtract the y's, over x2 minus x1. And so let's do the arithmetic here. We'll get negative 2 plus 4, which will give us 2, and 4 minus 6, which is negative 2, so the slope is negative 1. So there's our slope, m equal negative 1. Let's do the same thing over here. We can label this point x1 comma y1, x2 comma y2, and let's use the formula. And let's put in some values. So y2 minus y1 will be 5 minus a negative 4. And x2 minus x1 will be 3 minus 3. Well, here we have a problem because we end up with 9 over 0, and division by 0 is undefined. So what we say about this is the slope is that it has no slope. Not that the slope is 0, it has no slope. Well, what did we see up here about a problem that had no slope? That tells me what kind of line is this. It's actually a vertical line. If I were to graph this, this is a vertical line. Vertical lines have no slope. Okay, well, let's do some more work. Let's use the information about the line to find the equation of a line. And we're going to state the equation of the line in slope-intercept form and in point-slope form. So let's look at the information we've been given. I've got a slope equal negative 5, and it passes through the point negative 4, negative 2. When I'm given a slope and I'm given a point, then I'm going to use the point-slope form, which if I read above, it's y minus y1 equal m times x minus x1. So we'll just plug in our information. Negative 5 for slope, and this is our point for x1 comma y1. So let's write this as y minus a negative 2 equal to the slope, which is negative 5, times x minus x1, which is a negative 4. So I end up with y plus 2 equal negative 5 times x plus 4. I believe that's what they're wanting for point-slope form. Now we can take it and clean it up and put this in slope-intercept form. Slope-intercept form, let's just take it and clean it up by distributing the negative 5 to give us negative 5x plus 20, excuse me, not plus 20, minus 20. And let's take this and subtract 2. So if I subtract 2 on both sides, I'll have negative 5x minus 22. And 1 is the slope-intercept, point-slope form. This is point-slope form. And this is slope-intercept form, where you have a slope and a y-intercept. Let's look at this one. Part B. We have a slope of a negative 1/2, and it says it passes through the origin. Well, what they're doing is they're giving us a slope and a point, because the origin is the point 0, 0. So if I have a slope and I have a point, I'm going to use the point-slope form, y minus y1 equal m times x minus x1. And let's put in the information, but in this case, the x1, y1 will be the 0, 0. So y minus 0 is equal to negative 1/2 times x minus 0. Well, this is basically y equal negative 1/2 x. When I distribute my 1/2, I'll just get a negative 1/2 x. The two zeros go away. And so basically, that's the equation of the line in both slope-intercept and point-slope form. Let's look at these other two. We want to look at the line passing through these 2 points. Well, one piece that's missing is they haven't given me the slope. But I know that I can calculate the slope from the work I did earlier using the slope formula. So we need to find the slope first. y2 minus y1 over x2 minus x1. Negative 5 minus a negative 5 over 6 minus a negative 2. Well, 5 minus a negative 5 gives me negative 5 plus 5, which is actually 0. Now this 0 in the numerator is okay. It gives us a value of 0. So what I have here is that I have a slope equal to 0. I want to find the equation of the line. So let's back up here. I said something about an equation that has a slope of 0, and it's a horizontal line if it has a slope of 0. What type of equation does a horizontal line have? It's y equal to a constant. So in this case, my equation is going to be a horizontal line with y equal to a constant. And what's the constant going to be? Well, it's the number in the y position, that constant of negative 5. That one's a little different. Finally, let's look at this last one. It's going through the point x1, y1. I'm not given a slope, but I am given another point, which is a y-intercept, an x-intercept of negative 1, 0. So I have 2 points. 1, negative 3, 1 point. Negative 1, 0, my next point. So let's go ahead and use the slope formula to calculate the slope. y2 minus y1 over x2 minus x1. So y2 minus y1 will be 0 minus a negative 3. x2 minus x1 will be negative 1 minus 1. So I get 3 over negative 2, so negative 3/2. Now that I have a slope, I can use this slope and a point to use the point-slope form to calculate my equation of a line. Y minus y1 equal m